really go and view the Form 4 YouTube recording. So I hope those viewing the recordings are really my own students instead of other school students. Okay, because I've had a lot of experience over the years that when I posted videos into YouTube, right, it is other school students who's viewing it and not my own students. So hopefully the one viewing it this time is actually you guys. All right. Okay, so let's continue on. Okay, so we're going to go into applications of total internal reflection. These are very, very important because in terms of physics and in the technology nowadays, all right, total internal reflection is very important, especially fiber optics. Okay, out of so many um, total internal reflection application, fiber optics is one of the latest, all right, compared to the rest, and it is widely used nowadays if we want to have a 5G connection, 4G connections, and to transfer internet data very fast at the speed of light, because light is part of the electromagnetic spectrum. All right, visible light is part of the electromagnetic spectrum. So light can actually travels at 0.8 gigameter in 1 second. So if we want connection fast, we really have to understand regarding this fiber optics, and whose applications, whose basic physics concept is actually total internal reflection. Okay, so fiber optics, this is actually what I've taken up from the textbook. All right, it's widely used in the fields of telecommunication and medicine. Just in case you didn't notice, this one, not only it was in the textbook, it was also in the slides that I sent out 2 days ago. So fiber optics is actually widely used in the fields of telecommunication and medicines as well. All right, you know those endoscopy thingy that they actually put in, they open opening at their body, and then they actually put a tube inside. That is actually fiber optics as well. Okay, fiber optic is actually made out of pure glass and plastic fibers. Sorry, all right, pure glass or pure plastic fiber. It has to be pure, all right, because if it's mixed with other materials, then fiber optic, the light that is traveling inside there will slow down. All right, when it slows down, then it cannot travel at the speed of light already, isn't it? Now, the inner core, which has a high refractive index, so that's one keyword. The inner core must have a higher refractive index, surrounded by a layer of cladding with low refractive index. Because one thing, if you recall total internal reflection that I've taught you guys the other day, okay, so total internal reflection got two conditions. All right, the first condition is that it must move from a denser optical density or higher optical density to a lower optical density. So if it's a higher optical density to a lower optical density, okay, it also means that the refractive index of the inner needs to be higher compared to the refractive index of the outer layer. All right, because it's lower optical density. The second condition is the incident angle must be greater than the critical angle. All right, recalling what is critical angle. Critical angle is whereby if all right, critical angle is whereby, let's just say this is air, so refractive index of 1.00, and then the bottom part is actually, let's just say glass, for example, 1.50. So if let's just say the critical angle of glass, people cannot see anything. So I have to find the critical angle of glass, so that will be n equals to 1 over sine c. Someone help me calculate this, Rebecca, please. So sine c equals to 1 over n. Hey, I thought Rebecca's supposed to be in another session.
Oh,
One.
my teacher moved it to 5 p.m.
Ah, okay. All right. So, Rebecca, can you please help me calculate this? 1 over 1.5.
0.67.
0.67.
42.
It should be 0.667, right?
0.6.
Should be 0.66666.
Yeah, 0.6 repeating, 0.67 lah.
So try to have 3 decimal places instead of 2.
Oh, 0.667. Okay.
So C is actually
41.84.
41.84. Okay, so that's 41.84 degrees. So let's just say the incident angle I is the critical angle, that would be 41.84 degrees. All right, the refracted angle would actually be 90 degrees. R is actually 90 degrees. So this is actually critical angle. If let's just say the incident angle is more than the critical angle, okay, whereby the incident angle is, let's just say, 60 degrees. All right, what happens here is that the ray, the incident wave, will be fully reflected back. That doesn't look like. So in terms of physics paper 2, I would suggest, not only paper 2, paper 1 also, I would suggest you guys to bring a protector into the exam hall. All right, so please make sure you bring a protector into the exam hall. I'm not going to provide that for you guys. So over here, all right, so you have to actually measure 60 degrees and make sure the refracted ray is also 60 degrees. This is what we called as total internal reflection. All right, when it's total internal reflection, the incidence angle is same as the reflected angle. It's no longer refraction. All right, it's bouncing back already. Okay, so let's move back to here. Okay, so that are the two conditions of total internal reflection. So when the light signals enter one end of the optic fiber or fiber optics and experience total internal reflection, it will continuously it will actually keep on bouncing continuously in the iron core, the inner core, until it reaches the other end. The other end could be very, very far. It could be a few meters, it could be a few thousand kilometers. All right, as such, signals can be sent rapidly without the disturbance of electrical signals. All right, because electrical signals are due to electricity. Electricity, later on you will learn in Form 5, electricity needs conductor. Okay, then fiber optics inside is actually glass, pure glass or pure plastic fibers. So if you guys actually went to Sunway Pyramid, there's a concourse near Aeon that side, all right, closer towards Sunway Pyramid. During the Christmas decoration, they actually use fiber optics as the Christmas decoration. All right, so that is actually using plastic fiber, because glass fiber will be definitely very heavy and it's going to be very expensive as well. So over here, all right, inside is glass. Glass will not have any electrical signals. All right, so all the data that is being sent in the internet right now, they are all using fiber optics, which means it is light. All right, it is light energy that is carrying all our internet connections. All right, these things will be further learned, introduced a little bit in quantum physics Form 5. Okay, so this is optical fiber. All right. So another one which I included in my slides previously is this one, because I think this notes is much more completed. All right, if you look at this fiber optics picture, all right, it might seem like it's bouncing in and out very, very normally like that. But you have to understand that when the light ray actually move from the glass to this part would be a high optical density. All right, optical density and also high refractive index, whereby the outer one has a lower refractive index and a lower optical density. So please do take note, when it is a normal line, all right, if I draw a normal line here, the incidence angle is the same as the refracted angle, including over here as well. The incident angle I is the same as the reflected angle. Even when it bounces over here, I is still equals to R. So if you notice that even if the fiber optic is being bent, right, total internal reflection can occur. Why? This actually means that the critical angle of this fiber optic is very low. All right, the critical angle value must be very low. That's why it allows different angles to be reflected. Okay, So over here, fiber optics consists of a tubular rod, which is made out of glass and other transparent materials. All right, so the external wall is less dense than the internal wall, less dense in terms of optical density. All right, so when light ray travels from a denser internal wall to a less dense, at an angle that exceeds the critical angle. So these are all keywords in terms of applications. All right, total internal reflections can occur. So this will continue until the light ray enter the eye of the observer or it comes out from the fiber optic. So fiber optics are normally widely used to transmit signals through lasers. Lasers means light. All right, lasers means light. It can transmit signal faster and through long distance with high fidelity. Fidelity means here is that it allows a lot of signals being transferred without a loss of signal. It's very difficult to lose signal in fiber optics unless the fiber optic cable actually there's a cut or something like that, then the light suddenly moved out from there. Then you will lose the signal. All right. So fiber optic is also used in the endoscope for medical imaging. So I want to show you what's the advantage of using fiber optics. I'm used to call it fiber optics, but over here, in terms of notes, they call it the optical fibers. It's the same thing. Don't worry about that. All right. The advantage of using optical fibers cables over copper cables. Copper cables are the one that we're using right now to transmit our electricity. Our internet data nowadays, majority is using fiber optic. Okay, so the advantage is that fiber optics or optical fibers are much more thinner and lighter compared to copper cables. A large number of signals can be sent through them at one time. It can be a few hundred signals at one time. Okay, do give me one quick moment. Sorry. But I see a message. Is it possible to answer without protector or not? Ian, try not to. All right. Because if I'm being particular, if I think the question paper that's coming up on Wednesday is going to be an easy question, right? I'm going to be very particular about all this detailed stuff. All right. Does exam accept fiber optic? Yeah. All right. They will accept fiber optics. Okay, give me one quick moment. My dad, who's actually at hometown, keeps calling me for a while. Let me just let him know that I'm in class. Okay. All right. So over here, all right. A large number of signals can be sent through them at one time. Okay, transmitting signals with very little loss of over great distance. Okay, I just remembered one experience I had last time because I grew up with the internet. Okay, I started learning. I think I told you guys previously before. I started learning computer when I was in primary school, and I was learning about MS DOS. Then after that, Microsoft came out with Words, Excel, and dot. So I started learning that. And when I was in secondary school, only the internet started. So that time, internet started using phone cables, which means copper cables. So whenever we connect to internet and whenever we use the internet, right, the thing that we hate the most when we use the internet is someone calling the cable phone. All right, because the minute a phone call comes in, our internet connection gets cut off. All right, so it's either internet or the phone, and the phone always wins. Okay, so and whenever we want to get into the internet, we have to dial up the internet, and dialing up the internet could take 30 minutes to 1 hour the most. I think I remembered waiting for 2 hours for the internet to go up. So you guys are actually very, very lucky to experience internet moving at a very fast pace. So if you think your internet is slow, you should be lucky that you're born in the 20th century, okay? So over here, all right, signals are safe and also free from electrical interference. You guys, I'm just wondering, can you guys hear my girls screaming at the back just now?
Only slightly, chill. It's okay.
A bit only, yeah?
Yeah.
Okay. I'm waiting for them to go to sleep already. All right, signals are actually safe and free of electrical interference. All right, so they don't really get interfered if there's electricity nearby, and it can carry data for computer and also TV programs. So that's why nowadays TV box, you have the Mi Stick, you have our internet, all that. It all uses fiber optics right now, or optical fibers nowadays. Okay, so I'm gonna go into the question. All right, so this is a question from I've forgotten where already. All right, so anyhow, it's last year trials paper. So I'm gonna ask you guys to actually answer these short questions on this one should be fiber optic. Now, um first thing first, how do we know it's fiber optic? All right. In terms of question, all right, in terms of question, let's look. Diagram 9.1 and 9.5 shows a ray of light. A ray of light for you guys is definitely the light chapter already. In Form 5, that the word light could also be quantum physics. So a ray of light passing into glass and diamond respectively. There is only one topic that talks about diamond, and the specific subtopic that will be total internal reflection. No other chapters will talk about diamond. All right, and they give the refractive index, lagi obvious already that it's total internal reflection. So the first, you have two comparison. All right, comparison question in physics is actually at question number 5 and question number 6, and then section B essay. All right, it's a comparison question. So for me, moderate achievers means those of you who previously got B, C, and low achievers. All right, comparison question is a question that you must target. Do not worry about that this is a light chapter, that you're not very good in it, but comparison question is actually for low achievers to get marks. Why? Because you just need to compare the few things and then you relate them. All right, so please make sure, do not be scared by the question. Try to answer the question calmly. All right, my tips for students before exam is keep calm, breathe, don't panic. Okay, so what does it mean by critical angle? So I'm going to open up short answer right now, and I want to see your answer of critical angle. The question should be with you already. I sent it out just now, but I know some of you might not be able to notice that. Okay, I've forgotten one thing. Please enter class point. Someone just wants to pop in and say hi. So, ay. Okay.
Hello, Pon Young's daughter.
She can't hear you. Wait, let me unplug my speaker. All right.
Hello.
那是在哪里？
你看不到他们呢、他们在那边没有开镜头啊。他看到你们讲嗨，say hi。OK
你没按到这个。
OK，你不要按到东西啊，你出去找姐姐了。All right, for the rest of you, please enter class points already. All right, and start sending in your answers. Can I know who is A? Who is A? Excuse me, Daniel. Okay. The rest of you, please enter class point. And once you have entered class point, you can already directly answer the questions in there. All right. As usual, you can refer to your notes to answer your question. once you have already entered, you can directly send the answer in already. Now, if you want me to cover more questions, then it's better that you answer it fast. Alright, siapa Messi? Chong Wei, you got 2 account. Alright, for the rest of you who wants to enter the class point, the class point is going to be on the right-hand side top corner. Alright, the code is up there, 92241. So I'm going to close this one already. Alright, I'm going to close the class point in a short while. In another 10 more seconds. So I'm going to explain, I will discuss with whoever's answer that appears over here. Alright, closing submission. Okay, so critical angle, all right, actual answer for critical angle is the incident angle, all right, the angle of the incident. The incident angle when the refracted angle is 90 degrees. So let's see who got the correct answer. Okay, mana my pointer again. Critical angle is the angle of the incident ray when the angle of the refracted ray is 90 degrees. How come cannot just say angle of refraction and angle of incident? Okay.
I think I forgot the words, Joe.
Okay. In terms of if I see this in the exam, whichever exam it is, I'll have to think properly again and again whether I will accept this answer or not. Okay. Now, let's go next. All right, critical angle is the angle of incidence in a medium of a higher optical density when the angle of refraction is 90 degrees in a medium of a lower optical density. Okay, this one definitely should have hit spot on answer already. All right, angle of incidence in a medium of higher optical density macam sama punya, but then the back part when the angle of refraction in the medium of lower optical density is 90. Darren, salah because there's the degrees hilang. Please remember to write the degrees. Degrees is the unit for angle. Okay, Ian, when the light travels from a medium of higher optical density, sorry, sudah salah. Angle of the incident ray in the medium of higher optical density, this one almost similar to Xinyan's answer. It's just that Adelia, no need to write the word angle here. 90 degrees sufficient already. Okay. Huayong, angle of incidence in the medium of high optical density when the okay, acceptable. Incident angle in the denser medium when the angle of refraction in the less than medium is 90 degrees. Okay, angle of incidence in the medium with higher optical density when okay. Angle of incidence in the optical denser medium for which the angle of refraction is 90 degrees. Okay, this one I can accept. Ayo, I only asked one question there. Critical angle is the angle of incidence in the optical density when okay, this one I'm not gonna see this yet. Angle of incidence in the medium of higher optical density. Tak cukup, sorry Asbor. All right, the key is the other second part of the key is actually when the angle of refraction is 90 degrees. All right, critical angle is the angle of incidence in a medium of high optical density when the angle of refraction in the lower optical. Okay, this one good. Azwa, please take note. All right. Shuang here inside. Apa ini inside? I want this one to come up. Okay. Shuang, wrong spelling. Jawapan salah. Angle of incidence of the optically denser medium. This one I still can accept. Now, why this spelling mistake I cannot accept? This spelling mistake I can accept because physical terms, all right, physical quantity and specific physical terms must be correct. So incidence angle is the main keyword, all right, over here. Medium is not a priority keyword. So Xu Yang answer I have to reject, but Chongwei answer I still can accept because the incidence here is correct, the refraction here is correct. Okay, but problem is Chongwei tak ada degree, so Chongwei pun salah already. Angle of incidence beyond, which the ray of light passing through a denser medium to the surface of a, write degrees, spell degrees, not Chongwei, you just put the degrees there ma. To the surface of a less dense medium are no longer refracted. But okay, sorry, Quack, this is wrong. You are explaining about total internal reflection already. Total internal reflection does not happen when the incidence angle equals to critical angle. Please kindly watch back my video from the previous lesson. Okay, Junlin, angle of incidence in the angle medium of high optical density. Incomplete also, Junlin. All right, you need to have the second part, which is the angle of refraction in the optically less dense medium is 90 degrees. That one is the second part of the keyword. Okay, anyhow, good try. Okay, so next question is by using the refractive index of a diamond, calculate the critical angle. This is an image upload. Means that you can just snapshot your answer and put it up. I'm just going to wait for 2 minutes max. Hopefully there's answers already. Mr. Qiqi, the answer is yes. This question is a 2-mark question, so I'm going to show to you guys what is that 2-mark question is. So we have 3 answers already. I have 1 more minutes before I close submission. All right. Main reason why 2 minutes is because I want to cover more questions. It's not that I don't want to look at everyone's answer. So you better be fast. "30 seconds to go." All right, I'm going to close it. Okay, now, so here, right, Rebecca wrote formula is here. Substitution 2.42. Let's go back to the question first. Refractive index of diamond. Okay. All right, so substitution here is correct. The marks is actually for the substitution mark 2.42. All right, and then here 24.2 degrees. All right, so Rebecca gets 2 marks. Ray's answer 2.42. I see it there. All right, good. Ray also get 2 marks. Xin Yan, okay, 2.42. Mana my pointer pergi lagi. Okay, calculation wise. Okay. Okay. Xin Yan, just a word of advice, right? Try to rearrange the formula first without substitution, because get later when you substitute left and right, you might do some careless mistake in terms of bringing them over to the left and right of the equation. So be careful over there. But anyhow, Xin Yan's working is correct. All right, Xingming's working 2.42. Okay. All right. So you see, Xingming's answer and the rest of the answer is slightly different. Main reason is because the rest of them actually substitute the answer at the very last end. All right, but Xingming actually did 1 over 2.42 first, then she got the inverse answer of 0.413, and sine inverse of 0.413, she get 24.39. Now, if I see this, all right, what I'll do is actually I will key into the calculator also and make sure that the calculated final answer is correct. And if it's correct, I will accept the answer also. All right, so no worries that if your answer is slightly different from mine. All right, so this one, I tengah fikir sama ada saya nak bagi markah ke tidak. If I'm strict, I'm not going to give the marks. I'm only going to give the marks for here. But if I'm being lenient, I will give this mark also. Okay? Why is because, as you guys know, I would always prefer you guys to actually write the formula out. Now, formulas sometimes got mark. All right? Sometimes they give mark for the formulas, but when? All right? The answer to when the formula got marked is when the formula is not listed at page 2 and page 3. All right, so please make it a habit to write the formula from every single calculation question. Okay, so Ang Tirong. So Darren here, very obvious, is using his computer. Substitution. Okay, all right, acceptable, 2 marks. All right, okay. Next, okay, I'm gonna give you guys slightly more timing here. All right, probably about 3 minutes. The next part is actually to ask you guys to copy. You don't have to copy lah, okay? So what you have to do is just draw your diagrams onto the picture. All right, and then based on the answer in B1, all right, draw the arrows to represent the path of ray passing through point O. All right, so at point O, what happens to the path of ray? But please do take note that the one diagram 9.1 is actually glass. So which means that you need to calculate the critical angle for glass first. All right, so I'm giving you guys 3 minutes to answer this question.
So actually, they give us the critical angle of glass.
Oh, really?
Yes, there, 42. Bottom there.
Okay, good. Then it'll be easier for you guys to draw and analyze. Anyhow, 4 minutes. Draw your answer directly on your question paper and then directly snap a photo and send it in.
So do we have to like write every angle or just like uh
How many marks is this? 4 or 2? Look at the question. 4 marks or 2 question?
wait, where is the question? Oh, 3 marks.
3 marks. If it's 3 marks, you don't have to write because the question only says what happens after passing through point O. That's all.
Okay.
You don't have to make it bouncing all over the place.
Oh, we don't have to make it.
No, because they said just draw arrows to represent the path of the ray after passing through point O. Okay. Which means probably for diamond, probably you would
Okay.
need
So
lah.
diamond can, right? Okay.
Ijat, bila you nak guna your MOE account? 4 minutes already. Almost 4 minutes, and I only see Rabika's answer. Anyone else gonna submit their answer before I close submission and just use Rabika answer to explain? Ada? Tak ada?
Wait until 5 minutes, Cher.
Alright. Alright, it's 5 already, so I'm just going to close submission and use Darren and also Rabika's answer to explain. Alright, so we have Rabika's answers over here. So this angle is 40 degrees. So over here, alright, so which means one thing. Alright, now glass, in terms of glass, because the critical angle, alright, glass critical angle is 42 degrees. Alright, while the incident angle is 30 degrees, which means the incident angle is less than critical angle, refraction will occur. So when it's moving from a denser to a less dense medium, which is air, it will actually refract away from the normal line. So here Rabika gets it correct. Then over here, okay, let's have a look at this part answer. This will have total internal reflection because the critical angle for diamond that we calculated just now was 24.41. So the angle is 30 degrees. The incident angle is 30 degrees, which means it's more than the critical angle. So you need to make sure that you draw this 30 degrees exactly the same. All right. And when it bounces back, and then it will hit this surface. And again, you have to measure it. All right. Measure it. If you're going to draw a few direction like this, all right, at least make sure that you measure the angles and make sure these two angles is the same. All right, and then you reflect back up. And over here, I think the angle is less than the 29 degrees, so 24 degrees. So that's the reason why Rabika actually draws it out. So here, Rabika actually managed to get the 3 marks directly. All right, let's look at Darren's answer now. Darren's answer over here, okay, over here, unfortunately, Darren, your drawing is closer towards the incident. All right, so technically one thing, when you're moving from denser to less dense, you actually supposed to move away from the normal line. All right, from less denser to less dense, you're supposed to move away from the normal line. All right, so you could not get the mark from this side. And then over here, all right, even from my eye point of view, okay, I can tell you there's actually 2 things. Number one, if I'm being strict, Darren won't get any marks from here. But if I'm not being strict, I will still accept this answer. Okay, but being strict means what? Being strict means that I will go and measure. All right, the actual marking is actually I will have to measure this angle of the 30 degrees. All right, that's the actual thing that's supposed to be done. Okay, so that is me being strict. If I'm not strict, okay, faham lah. But the most important thing is the arrow is the drawn, all right, and it's also reflected back. And this one, to me, it doesn't looks like it's being drawn for total internal reflection, because the first thing is, if you want to draw total internal reflection, you must make sure that you draw the normal line first. When you draw the normal line, all right, for this surface, so for this particular surface, the normal line is somewhere here, you know. All right, so you have to use your ruler and draw the 90 degrees. Chong Wei question is, teacher, will you be strict during the finals? Depending on the question. All right, if your exam paper is easy, then I'm going to be very specific and detailed, which means AKA strict. If the exam paper is difficult, then I'll be much more nicer. Okay, so I cannot answer your question now. Oh. I haven't even seen the paper, ma. Okay, so over here, all right. So Darren, unfortunately, this part I can give you the 1 mark here, but I couldn't give you the 2nd mark already. All right, so Darren, please be careful. So in case this kind of questions for drawing angles, please make sure that you bring your protector inside the exam hall for physics paper on Wednesday. Yeah. Okay, next, this is actually a diagram that shows a submarine which uses a glass prism. Due to time constraint, I'm only going to show you the answer here. All right, a submarine which uses a glass prism periscope to see objects above the water surface. Now, this prism periscope is actually using prism. Okay, there are 2 types of periscope. There's a mirror periscope and there's glass prism periscope. Mirror periscope actually uses reflection, while glass prism periscope actually uses refraction. All right, so please be careful between these 2. Okay, but I think in terms of syllabus, this time it is more towards refraction already. It uses glass prism. And when it uses glass prism, it's under total internal reflection. How do you know it's total internal reflection? This is question C. You look back at question B. Question B is actually talking about the total internal reflection. So it is related. Okay, so with the help of diagram, explain how the observer in 9.3 can see the objects. This is 4 marks. All right, so this is actually a prism periscope that is taken out from your textbook, if I'm not wrong. All right, so number 1, all right, there's a few points over here that's inside your textbook. So there's 4 marks over there. So the first mark is that, let's see, should be here. All right, light rays from the object travel along the normal to the side AB, all right, of the upper prism, and then it reaches AB without refraction. All right, why without refraction? Because it is incident at the normal line. Okay, the angle of incidence is 45 degrees and it's larger than the critical angle of prism. Then, let me get all the highlighter. Okay, first mark is, all right, light ray from the object. Object travels along the normal side AB of the upper prism. Light ray reaches AC without refraction, so that's the first mark. Angle incidence is 45 degrees and it is larger than the critical angle of the prism. That is the second mark. All right. Therefore, total internal reflection happens at the side of AC and light is reflected downwards. That's the third mark. The fourth mark is, once again, reflected light rays experience total internal reflection at the side DF. And finally, the reflected light emerges from EF without refraction and enters the eye of the observer. So over here, you will notice there's around 6 points. All right, there's around 6 points, but there's 4 marks. So my advice to you is minimum 4 points, maximum 6 points. All right, but be very careful. Any point that was written wrongly, you will get wrong answer right. So be very careful with that. All right, so I'm going to discuss this question again because we've discussed total internal reflection quite a lot. So I'm just very quickly to explain to you guys this. You can screenshot this this answer later on. All right, this is one of the questions inside the PDF that I sent it to you just now. Okay, because I selected some questions to discuss only. Okay, so the structure of the optical fiber, right? You are assigned to give suggestion to the characteristic of the optical fiber so that it can be used in communication and medicines. State and explain your suggestion based on the following aspects: features, comparison of the refractive index, inner core and outer cladding, flexibility, impurity of the inner core and additional features. For your information, this kind of question, which means that they did not give you options, they give you suggestions, points, characteristics that you need to explain yourself. This kind of question will come out in section C. All right, that is question number 11. Only one question, no options anymore. All right, so this question is a compulsory question to answer. Okay, so in terms of this, all right, I'm gonna answer for you guys. Features of the optical fiber. All right, what kind of features of optical fiber? It needs to be a strong material. Now, features, it can be many things. It can be the thinness of the optical fiber. It can be a lot of different features. All right, so for optical fiber, I considered it, the feature is to be a strong material. Why does it have to be strong material? My answer is it do not break easily. So please do take note. Section B, question number 9 or 10, and section C answer, question number 11. Please, if it's a 10-mark question, if you see a 10 marks over there, I want to see this kind of table. All right, don't worry about writing full sentences or whatnot. All right, just give me the material or the features. The question actually asked like this. They actually ask features of the optical fiber. So maybe I could improvise even better by writing features, double dot, strong materials. All right. So this refractive index is very obvious already. Flexibility is also written there. Impurity, and also this additional info. All right. Additional aspects. Then double dot. All right. You can let the answer simple as this, and this is a 10-mark answer. This is the kind of answer I want to see in your section B and section C. Please do take note. Physics, section B and section C, write in the table. All right. Biology and chemistry is different style. Don't confuse yourself. Please don't. All right. So over here, all right, the refractive index. All right, refractive index of the inner layer needs to be higher than the reflective index of the outer layer. Why? So that total internal reflection can occur. All right, so that's one important keyword. This is the condition for total internal reflection. Next is the flexibility of the material. So flexibility of the material needs to be high with the reason so that it can bend easily. All right, and then impurity of the inner core, it has to be high impurity. Low impurity, sorry, shouldn't be high. Why? Because the inner core, if it's a glass, it needs to be pure glass. Pure glass means there is no impurities inside there. So my answer is wrong. It's supposed to be low impurity of inner core. If my understanding is correct lah, okay? So that the light wave can move at the speed of light. If there's other impurities inside there, right? Other materials other than glass inside there, other chemical atoms that is not glass inside the inner layer, light will refract. It will no longer move at the speed of light because when there's impurities inside there, it will slow down. All right, so that's why it needs to have low impurity. Now, other additional aspect is that I would suggest thin materials for fiber optics. Fiber optics are normally very, very thin. All right, explanation could be because it is lighter and it can use in small areas. All right, like for example, human bodies. All right, it uses fiber optics. Low density also corresponds to lighter answer. All right, so this is the answer for section B and section C type. Okay, now let's go to this other question. This question is regarding lens, which I wanted to cover today through questions. Okay, so all right. This question, what is the meaning of focal length? But before this question, let's look at the top. Object O is placed in front of a convex lens. The focal length of the convex lens is actually 4 centimeters. Now, there are actually two types of lens, very quickly to explain to all of you. We have two types of lens, one that bends outwards, the other one that bends inwards. Okay, these are actually lens. So the one that bends outwards, let me explain the inwards one. The one that bends inwards are actually called concave lens. Reason why it's called concave lens, because this caving in, all right, bending inwards, looks like a cave, all right, in the mountains. So normally when it bends inwards, my concept is the concave, all right, looks like a cave. So that's a concave lens. Then the one that bends outward will automatically be known as a convex lens. Now, convex lens, it's the lens that we use for magnifying glass, right? So what happens in a magnifying glass, it actually focuses the light rays that passes through it onto a single point. When it focuses onto a single point, that is what we call converging. So convex lens has another name called the converging lens. And I'm talking about lens, I'm not talking about mirror. And concave lens will actually spreads out. So spreading out means diverging. So concave lens have another name called diverging lens. Who's Eunice Ling? Okay, so this is actually the two types of lens, and I hope that you guys actually watched the YouTube video that I sent to you guys just now. Can I ask who's Eunice Ling? Is it any one of your classmates? Please do let me know in the chat box. Okay, so let's go back to the question. All right, what is meant by focus length? All right, focal length, sorry, focus blood. So do refer to your book, do refer to your notes, and give me the answer. Because this is a short answer, I am closing the submission in 2 minutes. All right, noted, Joanna. All right, closing submission. All right, so focal length actually has a very specific answer. Now, focal length actually, all right, the straight horizontal line is called the principal axis. And then when we have a lens in the middle, okay, this one is actually known as the optical center. This point is actually optical center C. Then we have the first line, which is actually the focal point. And then after that, we have 2F further away from lens. Whether it is a concave lens or a convex lens, is still 2F. All right, so what happened? Sometimes here is actually not C, but it could be a O also. So then after that, what else can we talk about? Okay, focal length. Focal length is actually from this normal line. I would suggest to you guys, if you guys actually experience questions on lens, do make sure that you draw the normal line in the middle here. All right, so from this line in the middle towards this capital F, this distance is actually known as the focal length. So here, distance between the focal point and the optical center. Okay, correct. Imran, be very careful of how you spell this, but anyhow, still acceptable. A point, all right, it's not a point on the principal axis. If it's a point, tips. If it's a point, it's going to be a capital letter. So that's focal point, a point. But if it's a distance, it's actually small letter. All right, so that's focal length. Okay, so distance between focal point and optical center, good. Focal point, optical center, focal point, optical center, distance, focal point, optical center, parallel light rays which passes through the convex lens. Sorry, wrong. All right, so okay, so that is actually the focal length. Now next is actually the ray diagram. Now I'm going to draw you the ray diagram for you guys first. So I'm going to open this back and mana my... Okay, I'm going to draw using here first before I ask you guys to show me your working. All right, how to draw the convex lens? Number one, okay, the easiest method to actually draw the light rays, okay, if you guys have already watched my video, okay, the easiest point to draw is actually draw the center line. From the top of the object to the optical center. So because I'm using laptop, alamak. So I have to be very careful when I draw this. Draw it straight with the arrow over there. All right. Next, because this is a convex lens, the focal point actually converges at the focal point. So I'm going to let it parallel to the focal point first. How do I see parallel? Is you notice I'm trying to let it be straight. Okay, how am I going to let it be straight? I'm looking at my number one line here. All right, it is actually inlined with that normal dot. Okay, so that's how I consider it to be parallel and 90 degrees towards the dotted line. Not the surface of the curve, but the normal line in the middle there. And then after that, from this point, allow it to pass through F. Okay, so I'll have to draw it very, very far. And then if you notice here, the rays are supposed to converge, but before that, I have to draw an arrow here and an arrow over here. So I will have to extend my first ray. So when I extend my first ray, still masih tak boleh. What just happened? Okay, so assuming that this is the arrow, so if the object is on the left and the image is on the right, then what you have to do is you have to make sure that you draw your arrow of the image from the principal axis towards the intersection point. All right, towards this intersection point. Normally in exam, the intersection point will not go out of the exam paper because I cropped this paper, so obviously it's out of the box already lah. Okay, so here, all right, normally drawing a ray diagram is a 3-mark question, so but here they only have 2. So what if it's 2, means that, okay, let's get back to here. If it's 2 marks, means 1 mark. All right, it actually means that 1 mark is actually for both rays, ray number 1 and ray number 2, provided with the arrow written there. All right, so that is actually for 2 rays. And the second mark is actually for the image. All right, and you must make sure that is the image arrow is actually a solid line. And you must label the image. All right, so assuming the intersection point is here, draw a very straight arrow because I'm using freehand right now. And then you have to label this as image. All right, so then only you can get the second mark. All right, so I'm going to open up the image upload submission and I want to see your ray diagrams. All right, so I'm sending it out right now.
So we draw it on the paper, right? Like on the printed paper. We don't have to redraw the entire lens and everything.
No need. Question number 7 is a structure question. Structure questions, normally you draw it on the paper itself.
Okay.
If it's question number 9, 10, and 11, then they might ask you to draw it on the test pad. Just a reminder, question number 9, 10, and 11 have to answer on the test pad. Don't answer on the question paper. I'm not going to mark the question paper. Only question number 1 to 8, I will mark on the booklet. 9, 10, and 11, test pad. Since this is image upload and you have to draw the ray diagrams, I'm going to wait for 5 minutes. 1 more minute to go.
Sure. Wait, I'm trying to like upload the photo, but for some reason it's not uploading.
Try to exit from class point and enter again.
Okay. Wait for me, Acha.
Mm. All right, it's already quite some time, so I'm gonna close the submission over here right now. All right, for the rest of you who wants me to check on your ray diagram, it's best that you practice and you pass it to me to check, all right? All right, so here I have Shinyan's working. Okay. All right, so Shinyan, overall I can see it's very good, but I would add one more thing. Can you please draw the arrow before it gets through the lens? Now, usually when a ray diagram, the arrow when we draw, right, the first arrow shows that it's the incident angle, the incident ray. All right, that's the incident ray. The second arrow actually shows it as a refracted ray. So both rays must have the arrow. So Shinyan, please do take note. And then the image is actually drawn over here. So image labeled I. So this one is actually 2 marks directly. All right, next is actually Xingming's working. Okay, Xingming's working, both arrows. All right, all the arrows are there, 1 mark. But unfortunately, Xingming, it would be the best for an image, right, to draw from this principal line down towards the intersection point. All right, that would be the best method of drawing the image. Not the best method, it is the proper method. All right, so Xingming, you can only get 1 mark because the image is actually hanging over here. Okay, next is actually Rabika's working. Rabika also image hanging over there. So Rabika only can get 1 mark for the ray. All right, the image needs to be from here to here. You don't have to draw such a thick arrow for the image. Just a stick arrow is sufficient enough. Okay, Rabika? All right, so
I wanted to make it look more like the object. I know.
it needs to be longer because the image is being magnified. All right, when it looks like the object, it means that it's the same size. The only part that is same size if it's the object is located at 2f. All right, if the object is located at 2f, the image will be at 2f, same height also. The size is the same. All right, so please do take note on this. Okay, lastly, Ang Chirong would definitely dapat kosong. Okay, why? The ray diagram is drawn, but there's no arrow. If you don't have the arrow, I cannot give you the marks for the ray. And then the image is being labeled, but mana the image? And can I know why the image has an O here? O stands for object. Alright, the image is supposed to be straight line vertically downwards. Alright, so that is actually drawing the proper ray diagram. No, it's the image. Alright, Anchirong, please make sure you watch back the video that I sent in the group. Alright, please kindly state one characteristic of the image form. Mana my class point. One quick minute for let me appear that. Oh, I've forgotten to put the. Okay. Sorry. Why? It doesn't want to appear already. have no idea why suddenly it doesn't want to appear. All right, so since it's not appearing, can you all please write your answer in the chat box instead of me trying to troubleshoot? All right, so what is the one characteristic of the image form? Real, magnified, good. Some more? Any other answers? Virtual, not really, Xinyan, it's not virtual. Inverted, yes, correct. Okay, so how do we explain the characteristic? Okay, now how do we explain the characteristic is by looking at the image. Okay, so first you look at the object. Initially, the object is pointing upwards. All right, initially object is pointing upwards, but the image when you draw, the intersection point is pointing downwards. When it's pointing downwards, it actually shows that the image is inverted. Okay, now in terms of the size, we measure by the height, object's height, and also the image height. The image is actually much more bigger size, so that's actually what we call as magnified. All right, and then after that, in terms of real and virtual, all right, for refraction, if the object and the image is at two opposite sides of the lens, then the image is actually a real image. Real image means the image can be formed on the screen. All right, that's the definition of real image. Okay, so so the characteristic would be like this. I tapes on a bit because I want to show you guys the simulation. So I'm trying to get it opened and running at the background first. Okay, then let's go back to our PowerPoint, right, while waiting for that to run. Okay, next is actually this question. All right, this question, can you please answer what does virtual image means? All right, what's that virtual image means? Yes, Joanna, you wanted to ask something? Or tertekan, Joanna? All right, so please do try to answer that. What does virtual image is while I'm trying to open up the simulation to show you guys this picture. All right, since it's a short answer, then it's going to be waiting for the 2-minute submission. All right, so over here, okay, what is virtual image? The actual definition of virtual image is image that cannot be projected on the screen. This is the correct answer. Virtual image cannot be formed on the screen. If I were to take a white piece of paper in front of the lens. Now, after your exams, I will show all this simulation, not simulation, I'll show this experiments to you guys after the exam. So after your exams, after the Chinese New Year holidays, please make sure you still come back to school. I'll still let you guys carry out the experiments. Okay, so Xingming answer is image cannot be seen and formed on the screen. All right, can be accepted. image form behind the screen. Behind the screen means what? Okay, the words that I'm finding for is cannot be projected on the screen. All right, that's the keyword over there. So Imran answer is definitely wrong. Image that cannot be projected on the screen, correct. Image that is formed from, nope, not really. All right, so I'm going to show you guys simulations right now on the refraction of lens. All right, so this is actually my lens. Now, this on the left hand side, this is my image. So if my image is a far away image, and let's say I make it very, very big. Okay, so the three rays that you're seeing on the screen right now is the three rays that we're supposed to draw. All right, before, all right, there's three rays, which is actually from the top of the arrow. If I'm going to draw an arrow, from the top of the arrow, straight passing through the optical center, passing refracted through it. All right, this is my favorite ray to draw because you don't have to bend here and bend there. All right, the second ray is actually first parallel to the principal axis, and when it reached to the normal point at the optical center, all right, and it will actually move towards the focal length. All right, it will refract towards the focal length, and then the third line is actually refracted. The incidence angle passes through the focal point first, reaching to the normal line, and then it will be parallel to the principal axis. If you were to draw all these ray diagrams to scale, exactly to scale, so in another words to say, it's best for you to practice drawing ray diagrams using a graph paper. So you would actually get all three lines intersecting a point, and that point, because you started drawing from the top of the arrow, so the intersection point would be the top of the image arrow as well. All right, so here, all right, the characteristic for this line is that object is far away from the 2F. The image formed is going to be inverted, real, and diminished, smaller in size. Okay, so if I move this to 2F, do notice that when I move it to 2F, let me put it slightly smaller. Later on, it's going to get too big already. All right, when it actually like this, when the image is actually located at 2F, when the object is located at 2F, image will also be located at 2F. Okay, so the distance is going to be the same as well. So that's a special characteristic that you have to remember. All right, then when it's getting closer towards the lens, object gets closer towards the lens, the image actually gets magnified. Okay, for me, I don't really memorize object location and then where is the image from. I normally draw the ray diagrams. So when I draw the ray diagrams, then only I will write down the characteristic of the image form. All right, so when it reach F, do notice the dotted line. The dotted line, all right, is actually going infinity. The two dotted lines are actually going infinity. So here image is formed at the infinity. All right, and when you actually make it closer, even more closer, the image right now is at the same side as the object. When the lens image is at the same side as the object, the image form is known as a virtual image, because you can, if normally the screen is over here, all right, normally the screen is over here. So if the image, this is a key for you guys, if the image is actually same side as the object for lens, it's a virtual image. If the image is same opposite side from the object, then it's a real image. That's a key point for you guys to remember. Okay, but this is for lens, not mirror. Okay, so but for a concave, whatever happens, the image will always be virtual. See, this is the image. Whatever happens, whatever position of the object, the image will always be virtual. Okay, and it's always upright and it's always magnified. Diminished. Okay, so this is actually the image formed. Okay, do learn how to practice more of this. Okay, so I'm gonna go a little bit one more question, I think. Okay, this question, I'm gonna directly answer the questions for you guys. So I'm gonna leave this and show you guys how to write this answer. Give me one quick minute. So to summarize the lesson, I'm going to answer this last question part by myself. All right. Okay, diagram 7.1 and diagram 7.2, no, 9.1 and 9.2 shows the light rays from two identical objects passing through the convex lens. Okay, so the keywords are identical objects passing through the convex lens. So lens is actually talking about refraction. Both lenses actually produce virtual image. Virtual image is when the object is located less than the focal point position. Okay, so F is the focal point for each lens. With reference of 9.1 and 9.2, compare the thickness of the lens. So if you want to compare the thickness of the lens, what I will normally do is I will definitely go and measure the thing. Even though you don't exactly need the measurement value, so I just agak-agak want to know whether which is thicker and which is thinner. That's all. Okay, you don't have to give the value. I repeat, you do not need to give the value. All right, so in order to answer this question, you can actually write a point form over there, or you can just write a complete sentence, simple. And since recently, I will always ask students to compare using one diagram as the beginner. So the question says compare the thickness. So my first answer would be thickness of the lens in diagram 9.1 is more than diagram 9.2. Full stop, skip one line. All right, full stop and then skip a line. The second question is actually asking us to compare the focal length. So my next sentence is the focal length. Right, focal length is actually this capital F from the lens, excuse me. All right, so we can see that from the lens here, then you would measure it. Like, it's best to measure it to know whether is it more or less. 9.1's focal length is less compared to 9.2. So as I said, I will always write 9.1. There's a reason for it later on. So the focal length in diagram 9.1 is less than diagram 9.2. Full stop, skip a line. All right. Size of the image. Now, 9.1 image is very big. 9.2, the image is actually very small. So, size of the image produced in diagram 9.1 is bigger than diagram 9.2. Full stop, skip a line. Then the question says, now here, please be careful. Do take note. Question says, relate the size of the image with the focal length and make a deduction regarding the relationship between the power of the lens and the focal length. Okay, so over here, there's two parts over there. One, okay, whether the question asks you to relate or deduce a relationship, we always use the word as A increases or as A is more, then B decreases or B becomes lesser. Don't use the word directly proportionate or inversely proportionate in a comparison question. The terms directly proportionate, inversely proportionate only applies to you see the formula inside that question itself, not because you know the concept, but you see the formula inside the question, or there's a graph in that question. They ask you to, based on the graph, you deduce the relationship. If like this, you cannot use directly proportional or inversely proportionate. All right, so here, relate the size of the image. So for me, I always love to use the word increase and decrease. So as the size of the image, as you can see here, I wrote size of image in 9.1 is bigger. And the focal length here is 9.1 is less. So I would say as my cos is actually the focal length. The focal length is the reason the size changes. So as the focal length 9.1 is less decreases, the size of the image produced All right, 9.1 is bigger ma, so increases. So that will help me to make it easy to see the relationship. I always start comparing based on 9.1 or 9.2, that's up to you. Okay, then skip a line. Make a deduction regarding the power of the lens and the focal length. So the power of the lens means how big can the image be formed. So the focal length of 9.1 is less, but the magnification is higher. Therefore, as the focal length decreases, sorry, the power of the lens increases. All right, so that is how we answer relate size and deduction regarding the relationship. Now, previously of the lesson, I did mention to you guys that comparison question is at question number 5 and question number 6. Confirm. Question number 5 and question number 6. And then I forgot the section B or section C question. They will ask you to compare. So you have at least 3 comparison questions in paper 2. So these 3 comparison questions, they will ask you these 5 things. 3 things they ask you to compare from the diagram. 2, they will ask you to relate. So this is the type of answer that I want to see in that 3 comparison question. Now, for those students who are low achievers, moderate achievers, high achievers, definitely even more, you should score this. For the comparison part, right, do not panic when you see the light chapter. Even the Form 5 students will panic, or the X students will also panic. When you see light chapter, but it's a comparison question, calm yourself down, identify what the question is asking you, then answer based on what you see. All right, because what they want you to interpret is at the relating part. All right, as the focal length increase, or as the focal length increases the power of the lens, only this part needs to know out of the question. They need you to understand even deeper syllabus. But these 4 marks, you just have to see from the question and answer to get these 4 marks, Okay, so it's, teacher, can you still get if wrong cancel right? If wrong cancel right, then 1 mark will be cancelled off. All right, if wrong cancel right, 1 mark will be cancelled off. Okay,